welcome to the Ambassador tutorial. In our class today, we are going to solve a question on kinematics under page 101. So looking at this question, it says, the position of a particle moving along the y-axis is given by y in the function of t equals t cubed minus 4t squared plus 60 then in meter. Y is in meters and t is in seconds. What is the object displacement? That's the first question. And the other question is an average velocity for the time interval from t equals 3 seconds and t equals 5 seconds. Anytime you are given a kinematic equation, the first thing you need to do is what is the kinematic equation first. So writing out the kinematic equation, this is where we have the kinematic equation. Digging it out, solution to this. Digging out the kinematic equation, we have y in the respect of t equals, in bracket, t in the power of 3 minus 4t squared minus plus 60, closing the bracket, meter. So when you're looking at the kinematic equation, the next to do is this kinematic equation. Is it an acceleration kinematic equation? Is it velocity kinematic equation? Or is it displacement or distance kinematic equation? How do you know? The way you can know is by considering the unit. The unit is less in meter. Even from the question, we are going to understand that y is in meter, and meter is always attached to either displacement or distance. So that means this kinematic equation is displacement, or we can call it distance. You are still right. So let's look at what we have to find. The first question says, what is the object displacement? So we have to find displacement. And also, we have to find average velocity. So we have to find displacement and also we have to find average velocity. So how can we get our displacement? In kinematics, the symbol for displacement is usually S in the arrow like this. Because we are dealing with our kinematic equation, we can have it as y, they can indicate your arrow. So what does this mean? It means that change in y. And change in y means my final y and my initial y. So it means that the difference between the displacement at final minus the displacement at initial is what we call the displacement we are looking for. So how do we know when the displacement is at final? And also how do we know when the displacement is at initial? It's by the help of your time. Your time frame will actually tell you. We are given from the question that the t ranges from 3 seconds to 5 seconds. So I can say my t1 is 3 seconds and my t2 is 5 seconds. So bringing the two together, I say that I can refer this my t2 to be tf and my t1 to be ti. That means t2 is my final time, my t1 is my initial time. So how would I use that to solve a kinematic equation? Firstly, find the final displacement. So my final displacement, remember, is y f equals to, writing out a kinematic equation, t in the power of 3 minus 4t squared plus 6t, closing the bracket, meter. Recall, we said our final displacement is when you have your final time. So at that time, my t is 5 seconds. So that means any place I have t, I'm going to put 5 seconds. So I have it here in bracket 5 in the power of 3 minus 4 in the bracket of 5 in the power of 2 plus 6 in the bracket of 5, then close the bracket. So in this case, 5 in the power of 3 is 1, 2, 5 minus your 5 squared is 25. So 25 times 4, that's 100, plus 6 times 5 gives you 30. So when you try to use your calculator, so at first 125 minus 100 will give you 25. So 25 plus 30, that's 55. So here is 55 meter, which is representing my final displacement. The next to do is to get our initial displacement. We've gotten our final displacement. Getting your initial displacement. So our initial displacement, we are still going to follow the same equation, which is y I equals your kinematic equation is given as 4 t in the power of 3 minus 4 t squared plus 6t closing the bracket meter. So how can we get our initial displacement? The way we can get our initial displacement, remember I told you that our T2 represents our final time and our T1 represents our initial time. So that means my T1 will be representing my initial displacement. And the value of T1 when time is 3 seconds. So what this actually means is that anytime I have my T, I'm going to put 3 seconds to get my initial displacement. So in that case, my yi equals to in bracket 3 in the power of 3 minus 4 in bracket 3 squared plus 6 in bracket 3. Then we have our meter. So in this case, 3 cubed is 27. 27 minus 3 squared is 9. 9 times 4 will give 36 plus 6 times 3 is 18. When you try to simplify this to calculator, you end up having 9 meter. So hence, that's the value of our initial displacement. So that's the value of our initial displacement. The next to do is to get our displacement itself. Because I actually gave the formula that says to get my displacement, hence to get our displacement, this is change in y, and change in y is written as yf minus yi. So the value of my yf is 55 meter, so it means 55 meter minus your yi is 9 meter. So when you subtract this, you are going to be having your answer to the 46 meter. So that's the value of our change in displacement. Next to get is our average velocity. Previously, we've gotten our initial displacement, final displacement to get our displacement. Now, we have to find our average velocity. So what is the symbol for average velocity? It's given as V, then you have arrow, which is indicating direction, then you have a subscript, heavy, representing average. The formula says that change in x over change in t. When the change in x means xf minus xi over tf minus ti. But for the case of our own kinematic equation, we say that y equals to t in the power of 3 minus 4t squared plus 6t meter. So I'm not going to put here as xf or xi. I'm going to put it as my va, which is my average velocity, will now be change in y, then change in t equals to yf minus yi all over tf minus ti. Recall that this my yf minus yi is already gotten as change in y, which we got in our previous question. So the only thing left for us is to find our tf minus ti. From the question given to us, we are told that the time interval is t equals 3 seconds to t equals 5 seconds. So it means my tf is 3 seconds, tf is 5 seconds rather, while my ti is given to be 3 seconds. So here I have tf minus ti. So all I need to do is my v, the value of my change in y over tf minus ti is now, change in y is given to be 46 meter over tf, which is 5, minus ti, which is 3. So that will be 46 divided by 5 minus 3 give you 2. And that can be written as 23 meter per second. Hence, the answer to this question is 46 meter based on the displacement, your semicolon, then 23 meter per second based on the average velocity. Let's look at the option. In the option, our right answer is option B, which is 46 meter, 23 meter per second.